Welcome back, everyone. Chris here again, and we're in our second session of the Lightboard review sessions. And so what we're going to cover today is what you learned in SC1x. That's the supply chain fundamentals. And the key phrase here was you learned how to make trade-offs. And so we learned how to make trade-offs between cost and service, between fixed cost and variable cost, and all sorts of other things, transportation and inventory, because logistics and supply chain is all about making trade-offs in your decision of your design. And so we focused on three areas: demand forecasting, inventory management, and transportation, but they all tied together in this total cost equation, which you should have tattooed to you somewhere on your body. You should know this by heart. And everything we do kind of ties into this. And so let me talk about each of these quickly, and then we'll talk about how it ties together in this total cost equation where we can make those trade-offs. So we start with demand forecasting. And so the whole idea of demand forecasting, you're trying to predict, sitting in time t today, what will the demand be in time t plus tau, whether that's a week out, a month out, a year out. And what we tried to get you to focus on was two main things: the whole idea of pattern recognition and then metrics. So understanding the pattern of your demand helps determine the methodology that you'll use to forecast that demand. So if you have a level demand, and so it's just kind of something sitting like this, it really doesn't change much, you can use some simple techniques like moving average, a naive forecast, a cumulative forecast, because that kind of says yesterday is going to be pretty much similar as tomorrow. And so you can kind of think about it going forward. But you might have something like a trend. Usually we look at positive trends, right? And in that case, some of those simple techniques fail. So we introduced exponential smoothing. And there's a whole series of different exponential smoothing models that incorporate level, trend, and seasonality. So I might have something like this. Whether it's across times of year, day of week, week of year, whatever my seasonality is, if I have a reoccurring pattern, then I want to use a slightly different technique. So all that we did in demand forecasting was determine which technique fits, to include using regression, which we learned in SC1x, where we take past history and we project what the forward demand will be. Now, once we come up with a demand forecasting model, we have to test it, and we use metrics. And whether the typical one we used most is the root mean square error, that simply looks at the difference between what you forecast and what actually happened, squaring that, and then we sum that, take the square root, because that fits in to our inventory management. You use that quite a bit. You can also look at mean absolute percent error, or MAPE. These are commonly used in industry, and it just tells you the percent of the error that you're off. Absolute means it's going to tell you how accurate you are. It won't show you bias. Remember, bias is if I'm consistently above or below my actuals, and that's why you want to use something like a mean percent error that doesn't have any absolute or squared terms in it to show if you're over forecasting or under forecasting. This shows bias. These show accuracy. So that's what we did for demand forecasting. We talked about new products and some other special cases as well, but we spent the lion's share of the time on inventory management. And we started off with an assumption of the demand itself, that it's deterministic. And this is a classic assumption, and this is where we developed what's known as the EOQ, or Economic Order Quantity Model. Again, we talked about this in SC1x. This is where you used first order conditions to find the trade-off between fixed and variable costs, where the fixed cost is the ordering cost. So that ordering cost, as I order more, my Q gets bigger, then the cost per item will go down. That's my ordering cost. And then my variable cost is the holding cost. And every item I have, if I order more, then I'm going to have those pieces will stay there longer. So my holding cost, inventory holding cost, will go up. And so what we try to do with this trade-off is we find the sum of these, and let's see if I can do this. And we find that minimum, and it happens to be where those two lines cross, and that's my Q star. Right? That's my economic order quantity. And it's all a basic fundamental trade-off between holding cost and ordering cost, because we assume that there's a fixed cost for every order. So you should know your EOQ backwards and forwards. But then we go into stochastic demand, and here demand is variable. So we go back to all those distributions we talked about in SC1x, whether it's a normal distribution, a Poisson distribution, a triangle distribution, any kind of distribution, to include an empirical one that you saw in practice. And you can break up stochastic demand into two big classes, and it's based on the horizon. The first is a single period. Am I only planning to sell Christmas trees, and I have a month, and at the end of that period, I got to get rid of them, fashion items. So these whole things about the news vendor problem, that's a single period horizon problem. The second is this infinite horizon. What if I'm going on essentially forever? So I always want to plan for going forward. And so you have two different approaches here. For the single period, we look at maximizing profit, and it all comes down to the idea of finding something called the critical ratio, where if this is my demand, and I want to find what the critical ratio is, because it's the trade-off between having a cost of shortage over the cost of shortage plus excess, and that tells me how much of this distribution I want to cover in order to maximize profit. And the math gets a little complicated here. We go through it, but the idea is that it's a single period and we're maximizing profit based on this distribution, and it's really trading off our risk of having too much and having too little. Again, it's another trade-off that's being used. For the infinite horizon, we introduced two classic models, the continuous and periodic, where continuous is I'm constantly monitoring how much inventory I have, and when my inventory dips below this reorder point S, I order Q, this amount. So it kind of ties together those two systems. And what determines what my S reorder point is my safety stock, and we'll talk about that in a second. Periodic is a little different, where I only check my inventory periodically. I check it once a week, once a month, and that's the only time I can check it and place an order. So that's every R time periods I order up to this big S. And these are just two policies that you can put in place, and they're widely used. Periodic is more widely used in retail. Continuous can be used in some other areas. It's really a trade-off of what it is you're monitoring and what the cost of the item is. And you can determine these policies based on minimizing cost or setting it to a service level, and I'll talk about that in a second. The last thing we did was talk about transportation and warehousing, and this was more familiarization. We described what transportation systems look like. We described warehousing, the basic techniques that are used within a distribution center, and so that was more just getting familiar. But we also introduced some of the concepts that happen with transportation when the lead time, for example, is variable itself. Not just the demand, but the time it takes to ship something, say, across the ocean, that is also variable. So then it gets a little more complicated. So demand forecasting, inventory management, and transportation and warehousing. How do they fit in? Well, when you look at forecasting, let me do forecasting in red. What it's really helping us determine is what is the expected demand, right? So that's all of these D's are coming from your forecast. But more than that, this standard deviation, part of this, that's not necessarily the standard deviation of the demand, it's the standard deviation of the forecast error, or the root mean square error of your forecast. How far off is my forecast? So forecasting influences the total cost equation that way. When I look at transportation, it affects me in terms of my cost per item or my cost per transaction that it takes. If I have to pay for the whole ship, the whole container, the whole truck. It also influences my lead time here. So this is, remember, my pipeline inventory. And it also influences, let me put a box around this, the variability of the transportation itself. Because this is the variability or the standard deviation of the demand over the lead time. So if both of those things are random or stochastic, it gets a little more complicated. So each of these tie into this whole total cost equation where I have my purchasing cost, my ordering cost, my inventory holding cost, whether this is for straight deterministic for cycle stock, for safety stock, and then for pipeline inventory. And this last phrase is really a loose phrase for stock out costs, where I have a probability of stocking out for each replenishment cycle, times the number of replenishment cycles in a year, times the cost of stocking out. And there's different ways that we've incorporated this. So if I put a cost for stocking out in, then I can look to minimize the cost of each of these policies to set this S and set this Q. If I don't have a cost there, I can set it equal to meeting some service level, whether it's a cycle service level, right, where I will make sure that I don't stock out certain percent of the time, or I can use an item fill rate. And these are things that we went over and over again. But again, to step back, it all ties back to this total cost equation. And so you're making trade-offs between your forecasting, your transportation, and your different shortage and excess costs within your inventory management. So hopefully this tied things together in what you see in SC1x. So good luck studying.